Hello everyone. So welcome to the classes for Geography, General Studies, and this is a foundation batch. Some of you were there in our crash course as well. So welcome again. Now the foundation course for Geography includes prelims as well as for mains, and overall picture of geography will be discussed here. So this is the introduction session for most of you, and we have had the introduction session for those who had joined in the crash course classes. See, so far as the geography is concerned, I've seen a lot of people getting trouble with geography because most of us think that geography is about remembering places, plateaus, plains, mountains, resources, cities, etc. Yes, it is a part of geography, but majority of geography deals with the conceptual understanding. It deals with understanding the phenomenon of Earth and how the processes that take place on the surface of Earth affect human life. So that interrelationship between man and nature is to be discussed in geography, right? And so far as the geography classes are concerned, for general studies, we have been telling that NCERTs are the utmost importance. NCERTs are the basis. So here we will be discussing about the significance of NCERTs, right? First, syllabus for geography, topics that we are going to cover in geography. See, there are three broad headings or broad classifications of syllabus that we do here. We divide the geography in three parts. First is the physical geography, right, in which we are going to discuss three major topics, which includes climate and climatic conditions of various places. First, we'll understand the concepts of climate like temperature, pressure, humidity, precipitation, cyclones, anticyclones, and then towards the end we are going to discuss about the climatic regions of world and how these concepts are applied in different parts of world, like what is Mediterranean climate, what is China type, what is British type climate, what is monsoonal type, savanna type, all these types of climate. To understand these climates in totality, we should be very clear with the concepts of climate, basic concepts. Then after this, after having discussed climatic conditions, we'll relate the same with oceanography, right? We'll discuss different phenomena that take place on the surface of ocean, primarily ocean currents, tides, waves, right, the oceanic circulations. And towards the end, we'll be discussing about ocean topography and also discussing ocean resources. Now for mains examination, the resources are very, very important. The new resources that we discover in oceans and what are its implications, climatic, economic and social implications, right? That will be very important. Ocean currents is also very, very important for your mains as well as prelims examination. There have been questions asked from ocean currents. So this topic will deal with all these phenomena that take place on the surface of oceans. Then we have third topic, which is the geomorphology, right? Geomorphology, and the geomorphology primarily deals with studying the concepts that takes place on the surface of Earth, like how plateaus are formed, mountains, volcanoes, faults, earthquakes, tsunamis, and also relating it to the disaster management part. So geomorphology will deal with all such concepts that takes place on the surface of Earth, lithosphere, after discussing the internal structure, and also will discuss different landforms formed by erosion process like glacial, karst, fluvial, aeolian or wind erosion. So all this will be discussed in the first part of geography, that is of physical geography. Right, this will be our sequence of classes. Geomorphology deliberately I take towards the end, although in books you will find this as a first topic. Now once we are done with these concepts, the physical geography, we apply the similar concepts over Indian conditions, Indian physiography. So this becomes our second part of geography, Indian geography, where the emphasis is on physiography, right, the physical settings of India, physiography. So in this topic like geomorphology, we study topics such as mountain building, and here we discuss formation of Himalayas. So there is an interconnection between this topic, geomorphology and physiography. So first part we are going to discuss the concepts, and then later we'll apply those concepts in Indian physical settings. Then the next topic would be of monsoon, Indian climate, monsoon and related concepts, right, regarding Indian climatic conditions. So if you understood seasonal winds, if you can understand seasonal winds, you can understand monsoon. If you understand ocean currents and El Nino, you will understand the effect of El Nino on Indian monsoon. Similarly, Indian Ocean Dipole and its effect on Indian monsoon. Western disturbances and effect of western disturbances on agriculture. So this is again very conceptual, can be understood once we are done with the concepts of climate and understanding the basic idea of seasonal winds and so on. After that, we'll be discussing topics like drainage system of India, soils of India, right, and the vegetation which overlaps with your environment ecology as well. When we study major biomes of world, now here we will be talking about biomes in India, and more specifically the economic aspect and ecological aspect of different types of forests that are present in India, right. Now apart from this, once we are done with the Indian geography classes and physical geography, see, the very important aspect of geography is the application of these concepts for the betterment of human life. As we define geography in two terms, that is, one part we study the nature, we study the physical aspect, on the other end we study the human activities. So the impact of these physical phenomenon, impact of the natural process on human life, and what is human response to such processes. This makes the third part of geography, which is called as human geography, right, human geography. And one of the earliest impact, one of the first activity of man is agriculture. So we are going to discuss agriculture. First, a brief classification of agricultures of the world, like what is plantation agriculture, what is subsistence agriculture with paddy domination, without paddy domination, commercial livestock raising, commercial dairy farming, truck farming, such terms which are standard and seen in different parts of the world. And then coming to Indian specific terms such as the new types of agriculture, like organic farming is one, and the various types of organic farming that is being practiced or that is a future. Then we'll discuss about green revolution, the impact of green revolution, ecological and economic aspect of green revolution, and the need for second green revolution and what can we do for the second green revolution. Along with that, there will be topics like white revolution as well, and where we'll focus on the livestock and dairy farming, and some topics like cropping pattern of India, which includes the topics of your general studies paper 3. Then after agriculture, we'll be discussing about industries. This topic is very well mentioned in your syllabus, right? Distribution of world industries, primary, secondary, tertiary. So after having done the classification of industries, we'll see what are primary industries, their location across the globe and India. What are secondary industries, their location in the world and India. And then tertiary industries the same ways. And then the problems and recent trends of industries, especially related to the geographical factors like resources, labor, market, and how the dynamics of industries are changing with the changing technology in developing countries, more and more labor in developing countries, how the industries are shifting their bases towards this part of world. Then we'll also discuss some topics of population which overlaps with the Indian society, right? The demographic transition of world and demographic transition of India from 1901 till present time, like the latest census, 2011 census, and how demography of India has changed from the stagnant phase to expanding phase to an exponential phase, and can Indian population get stabilized in future, what are the policies, etc. We'll also have a look around at the languages and various tribes of India, the geographical distribution of tribes and their economic activities. Apart from this, we are going to have discussion. Apart from population, we are going to have discussion on resources, because when we talk about population, so resources obviously are very, very important. Now the trend in examination, if you have observed the previous year question papers, you will find that the resources are important. Yes, knowing resources, whether it's energy resources, non-metallic, metallic resources, that's very important. Future resources. What is becoming more trending or more important now are the problems related with the extraction of these resources, like shale gas extraction, fracking, and the ecological impacts of fracking. Like what are the problems with the acid mine discharge? What are the problems related with the coal extraction and related issues? So it will be very current oriented topic, resources, and of course agriculture and industries are also current oriented, but the trend has completely changed in the case of resources. It's more about the impact on environment that has been asked in the exam. So this will be a border, like you can say a borderline of geography. We have drawn the kind of boundaries of geography syllabus, and within this boundary we are going to have discussions related to various topics. Now there is one topic that I have not deliberately mentioned, because we know that this is a part of geography, right? That is the regional aspect. Regional aspect. We cannot separate regional aspect from geography. Regional geography is a very, very important branch of geography where we discuss different conditions of continents. We'll have a discussion on all the continents, their population, their economic aspect, the major physiographic settings, and the climate and vegetation of that. So it will be an elaborate discussion on maps, right? So this is the syllabus for geography, and now the question is about books. Books that one should refer to complete this topic. For books, I would suggest, see, there are so much of material, there's so much of information available on internet, available by various sources, etc. You must have collected so much of material also, but still books, NCERTs are the base. In fact, NCERTs are one of the best books that one should always refer to. NCERTs will start with 6th, 7th and 8th NCERTs, right? And I'm writing here, it should be old NCERTs, 6th, 7th, 8th NCERTs. Now this will cover your regional aspect. There's a map of Africa mentioned there, there's a map of South America mentioned there, there's a map of Australia, all the continents are mentioned there. I know most of us have read 6th standard, 7th and 8th standard NCERTs obviously, but still we know that many concepts were not clear during school days. We did not probably look at the way it should have been looked upon. So geography was just another subject for us, we did not look at in detail. So my suggestion would be, even if you know a lot of things, please go through 6th, 7th and 8th NCERT. It will strengthen your base and will also provide a lot of information to you. Apart from that, you can also read 9th and 10th NCERTs, but so far as classes are concerned, 11th standard and 12th standard NCERTs. They're very important. It's not that we have to read line by line, we have to read between the lines also. There is so much of conceptual understanding required to understand the NCERTs. Classwork, all the classes that we are going to have, it will be elaboration of NCERTs, 11th and 12th standard NCERTs, primarily that, with of course with some updation also. So if you want to develop a very good concept of of geography, 11th and 12th NCERTs are the base. It's very, very good, and as I said, you should read between the lines also, right? Many a times when we take NCERTs, it's very thin book, it's not, and we start questioning whether it is enough or not. For those who think that NCERTs are enough or not, there's a question mark. Please read NCERT once. For all those, read it carefully and try to understand all the concepts mentioned in these NCERTs. You will understand that it is enough to understand geography. Now, what should we do for the current updation part? And this year prelims, 2020 prelims, has given us an idea, has shown us that there is The Hindu newspaper, which is very, very important. Read the science and technology page. There are so many questions that have been asked in this prelims. Read that carefully, right? Another magazine, another source that I would suggest is Down to Earth. At least some issues of Down to Earth are very, very useful, especially related to the resources and impact of extraction of resources on environment, impact of agriculture on environment, and such questions have been asked. So, and new techniques are also mentioned there. So, some issues of Down to Earth you must read. If you read all, very good. But at least important issues you can choose by the title itself, you will understand. Then Yojna, right, plus Kurukshetra. These two magazines, I'm sure most of the civil service aspirants take Yojna and Kurukshetra, but whether they read or not, that depends upon them. So Kurukshetra is very important, especially when it comes to topics like agriculture, irrigation, water resources. There are excellent articles, there is a lot of information mentioned there that will be very, very useful for you to write answers and handle question in prelims as well. So this will be the source for geography. Now there are many books that have been mentioned apart from this, apart from NCERTs, like there is a book by G.C. Leong. You can refer to this book, no problems, but after reading NCERTs. Once you are done with NCERTs, at least 3 to 4 times, I would rather suggest 5 times at least, you repeat, you revise that topic, and then go to G.C. Leong. Because if you start reading G.C. Leong, it tells you about the concept but doesn't explain so much. So having a base from NCERTs, G.C. Leong will be then suitable for the updation or enhancement of your knowledge. So far as current aspects is concerned, these are the sources for current affairs or current events related to geography, agriculture and so on. So, and one suggestion that I would want to give to all of you is that read one book 10 times rather than 10 books one time. If you revise again and again, you will get better insight, you will have better understanding, and then you will develop the confidence of writing answers. Many a times we read it once and assume that we will remember it, but it doesn't happen that way because we have a memory, there is no memory card. So in order to strengthen your memory, to enhance your knowledge, please make sure that you revise it 4, 5, 10 times. That will be very, very useful. Clear? So this is about geography syllabus and topics that we should, or the sources that we should refer to complete the geography. Apart from the basic understanding, these books, etc., we are also providing these classes to all of you, right? So you can refer to these classes and develop the concepts. If you have any doubts related to geography and any such that, you can always write to us. You can always reach for your doubt clearance. We'll have a separate doubt clearance session as well. Clear? And now let us start with what is geography and what are we going to discuss in geography, right? So far as the geography understanding is concerned as a subject, right? Before I go to the this definition of geography and what is to be studied, for how many marks are we studying geography? This is also very critical, very important to understand. After all, we are spending so much of time, how much marks are expected. See, paper 1, now if you see, almost near to the half of the questions are asked from geography. So we expect somewhere around 80 to 100 marks from paper 1. Right? It's written as world geography. But what is at times important and we somewhere overlook it is general studies paper 3. If you have analyzed the syllabus of general studies paper 3, you will see that the topics are mentioned as cropping patterns of India. And the question was asked in general studies paper 3, the rice and wheat pattern, the cropping pattern of rice and wheat, and why the productivity of rice and wheat has declined over the years. So such questions will also be dealt in geography. There are topics like irrigation mentioned in your general studies paper 3 will be dealt in geography. Topics like disaster and disaster management in geography. So in paper 3, general studies paper 3 also will be covering somewhere around 40 to 60 marks. So the discussion that we are having for geography here will be covering somewhere around 120 to 160 marks. Obviously, the variability is so much in UPSC exams. So we are taking a range of around 40 marks. So 120 to 160 marks will be covered by these classes, provided you follow instructions, provided you follow these magazines, Yojna, Kurukshetras, Down to Earth and The Hindu. Apart from that, whatever you want to read, you can read, but make sure that you don't compromise on these sources. They are very, very useful for exam. Right? So now what is geography and how do we study geography and what should be the approach for geography? See, geography, we generally say it is a study of Earth. But Earth as a home of man. There are two subjects which are similar, geology and geography. We are not studying geology here, we discuss geography. So what differentiates geography is the study of Earth as a home of man. This means that on one side, we emphasize upon the natural process, we study the various aspects of nature. Various aspects of nature. So what do we mean by various aspects of nature? We mean the climate, atmosphere surrounding us, the surface on which we are standing, that is lithosphere, hydrosphere, that is oceanography. When you put all this together, it becomes a biosphere. So biogeography. So all the natural aspect has to be studied here. We call it as physical geography, right? Then we study, on the other hand, agriculture, industries, population, resources, resource extraction. Now this is related to man, isn't it? Agriculture is done by man, industries are set up by man, resources are extracted by man. So the impact of nature on man, and what is man's response to nature. So on one part of geography, in this part of geography, where we are going to study about the climatic phenomena, atmospheric disturbances, atmospheric phenomena, then oceanography, then geomorphology, here we are going to study the human activity, human population, human settlements, industries, agriculture. And how agriculture is influenced by natural setups, natural conditions. For example, the best example can be India. Right? Any country can be an example for this interrelationship. But India, if we look at, see, majority of part of India is agriculture. It's human activities, agriculture. Why is it so? Is because if you see the northern plains of India, the largest alluvial tract in the world, northern plains, which is very fertile, also drained by so many rivers. Deccan Plateau is the largest volcanic plateau of the world. Fertile. So when you combine northern plains and Deccan Plateau, India has the largest agricultural region in the world. In geomorphology, we'll discuss the erosion and we'll discuss the formation of northern plains of India. We'll study the formation of plateaus like Deccan Plateau. And then we'll study how fertile are these soils in physiography, in physical geography. So if there's so much of agricultural land, fertile land, what is the response of man? Agriculture. Climatic conditions are suitable for cultivating particular crops like rice. In western part of northern plains, climatic conditions are relatively cooler during winters. Temperature is less. So it's suitable for wheat cultivation. So here, this is an example of response of man to natural conditions. Similarly, we are going to look at the different aspects and see the two components of geography, how are they related. The study of that interrelation between man and nature is what is called as geography. There needs to be the balance between nature and man, the forces of nature and the activities of man, isn't it? The forces of nature should and man activity should be balancing, rather should be in equilibrium. And if there is an imbalance, if there is a disequilibrium, right, that inequilibrium caused between man and nature, this is going to lead to disaster. Disaster. So the event of destruction And this disaster can take place if the natural forces get stronger. So called as natural disasters. Sometimes human activities go beyond the natural limit, or we can say elastic or carrying capacity of nature. So this man-made or human disasters. So man-made disasters are natural disasters, right? It occurs because this inequilibrium, there is the imbalance between man and nature activity. So this is all about the syllabus for geography. On one part, we study the nature, man, and study the equilibrium between the two. And in some cases where equilibrium is disturbed, it can lead to disaster, whether it's natural disaster or man-made disasters, and we should be prepared for disaster, right? So from the disaster, post-disaster rehabilitation, etc., to the disaster management, that is preparedness for disaster, to the disaster risk reduction. There are stages of disaster management. From the times when we used to have contingencies, that if there is a cyclone, if there is a tsunami, if there is an earthquake, if there is some flood or drought, we should be ready for that, like the post-disaster. Now we are talking about prediction and preparedness for that. And now one step further after 2016, there is one step further we have gone to. And what is that? Disaster risk reduction. We have to reduce the risk of disasters, because disaster is equal to vulnerability and event. When vulnerability meets event, it leads to disaster. So if we cannot focus upon event, we need to focus upon vulnerability, reduce the poverty, reduce hunger, improve health conditions. This is going to reduce the risk reduction. Rather, this is going to lead to the risk reduction. So this is all about syllabus. To reach up to the disaster and disaster management, we need to first focus upon the natural process, understand what causes earthquake, what causes tsunamis, what causes cyclone, what causes floods, how man activity can be in tandem with the natural forces, and finally disaster management and disaster risk reduction. This will be the syllabus for geography foundation course, and cover up your prelims and mains examination. Clear? So having done with this introduction with geography, let us now start the basic concepts of geography, which I'm sure most of you know. I'm sure that we know about the geography concepts, what is about geography and all that. So let's have discussion on that. Some basic concepts. Ultraviolet radiations, and this cycle of conversion of O2 into O3 and O3 back into O2 and O is called as Chapman's cycle. Chapman's cycle, or it can also be called as ozonocycle. So the energy carried by ultraviolet radiations is imparted to oxygen molecules to break it. Once the oxygen molecule is broken down into atom, it gets converted into O3, right? It combines with oxygen, O2, and forms O3, and the process continues. This is how ozone is formed, and this is why ultraviolet radiations can be prevented or can be stopped in the stratosphere or lower stratosphere itself. This is Chapman cycle or ozonocycle. And by this way we can understand that ultraviolet radiations ozone acts as a shield. So it doesn't actually act as a shield that stops something, that reflects back the UV rays. No, it actually uses the ultraviolet radiation, the energy of UV rays, in the formation and reformation of ozone, or this Chapman cycle. Right? So this is one point that you should understand. There is another point. Let's relate to this point again. And note down this point, that thickness of ozone is lesser in polar areas, it's higher, it's thicker in tropical areas, right? The extent of ozone is very less in case of polar regions, and it's very high in case of equatorial regions or tropical areas. Why is it so? So why is thickness greater in polar areas? What is required for the formation of ozone? Sun rays. Sun rays are more intense, right? Sun rays are intense in tropical or equatorial regions. So there will be continuous formation of ozone, right? More rapid formation of ozone, isn't it? More rapid formation of ozone. So thickness of ozone is greater at tropical areas and it is lesser in polar areas because the sunlight is relatively lesser in polar areas. If sunlight is less, obviously UV radiations are also less, right? So thickness of ozone is lesser in polar regions. Then comes another question. You must have heard about ozone depletion. Sorry. Must have heard about ozone depletion. Right? Ozone depletion. Where do we have most of the ozone depletion? The ozone depletion mainly takes place in polar regions. So that ozone hole has been seen in polar regions, Antarctica and Arctic. Why is it so? This particular answer will be completed in a discussion on pressure belts. I'll just give you a hint here. See what happens, the temperature in polar areas is very, very low. So due to that, there is a lot of subsidence of air. Like suppose if I draw here, or we draw the polar regions here, and this is suppose 90 degree north or south. Because the temperature is extremely low, so air will always subside, it will sink, right? Because it's very dense, it will also sink, and therefore it forms a vacuum like condition, a low pressure condition in the upper part of troposphere or lower stratosphere. So now because it creates this low pressure zone here, there is huge amount of sinking of air from the stratosphere, and also attracts air from different regions but the tropical regions, where in the tropopause, in upper troposphere or lower stratosphere, because air is sinking there. So all these CFCs, aerosols, aggregate near this intense low pressure zone formed over polar latitudes in tropopause. This is also called as polar vortex. In technical terms, if you see, this is called as polar vortex. Polar vortex. We'll have a discussion on polar vortex. Don't worry about it. It will be discussed in the classes for pressure belts. So what does this vortex do, and what is meant by vortex is that circulatory movement of air. Where is this air coming from? From the lower latitudes, from tropical areas and so on. Right? The air is very dense, it's very compact, therefore it sinks due to very, very low temperature and creates a vacuum like condition there, and therefore all air is, it's like the whirlpool formed in a river or any water body. If you've seen a whirlpool in rivers especially, all the water is moving in that empty space and forms a whirl or that swill. You will also notice that the other things also get carried away. Plastics get carried away, suspension present in rivers get carried away, all the polluted etc. Whatever is present in the river, it gets carried away to that whirlpool. Similarly, CFCs, aerosols, all these ozone depleting substances, they get carried away to the polar areas and form polar stratospheric cloud, PSC. And then we can understand that more CFCs, this chlorofluorocarbons. See, fluoride, let's pay attention here again. This fluorine is the most reactive gas on earth. Most reactive gas. So once it reaches to the stratosphere, once it reaches here, it starts breaking this ozone and forms fluoride oxide. It forms fluoride oxide. So therefore, oxygen forms a bond with, that nascent atom forms a bond with fluorine. Or similarly, chlorine forms bond with the oxygen. So if they form a bond, there will be nothing to interact. Remember this point. Ultraviolet radiations will not interact with oxygen any further because they already have a strong bond formation. Not only will it lead to the ozone depletion, but also will lead to the penetration of ultraviolet radiations to the lower atmosphere. Right? Lower atmosphere. This is how and why ozone depletion is taking place in polar areas. Polar vortex and chlorofluorocarbons contribute to the ozone depletion because they form bond with oxygen, and the interaction of ultraviolet radiations with oxygen does not take place. Right? It does not take place. That is about stratosphere. So remember this Chapman cycle, it's important, right? So let's go back to the discussion here. So what we are discussing was stratosphere, right? Ozone being the lowermost part of the stratosphere, dense layer of gas, right? And all this O2 plus O and forming O3, everything is taking place in the lower atmosphere. I mean in the stratosphere. By this 50 kilometers, by the distance of vertical distance of 50 kilometers, 99% of atmospheric concentration or gases are located. 99% of atmospheric concentration is located within 50 kilometers. Within 50 kilometers. So, as we move above this, like we go towards thermosphere and all, right, 300, 400 kilometers, it's just 1% of atmosphere. So, there is a transitionary layer here, exists up to 80 kilometers, called as mesosphere. Mesosphere. We don't have much to discuss in mesosphere. Why? Because it's a middle layer. Meso means middle. A transitionary layer. A layer of separation between lower atmosphere and upper atmosphere. Lower atmosphere is very cool, very cold. Maximum concentration is found there. And if we go above mesosphere, you will find high temperature, ionized layers, charged particles. The pattern of atmosphere or the characteristics of atmosphere is entirely different there. Right, which becomes a part of thermosphere. So some geographers even do not mention mesosphere, right, because it's kind of a very stationary layer, very calm layer. Concentration of gases is very minimal because maximum concentration lies below this. Temperature changes will be very, very minimal. It will be very low, right? It will be temperature is extremely low there in mesosphere. So just a transitionary between lower atmosphere and the upper atmosphere. And then when we go beyond mesosphere, there is this massive, very, very important layer that we have to discuss now, that is called as the thermosphere. That is called as thermosphere. The word thermosphere means temperature should be higher. It's beyond 80 kilometers to 200, 300, 400 kilometers, like that. Now thermosphere has very high temperature. Now this high temperature that we are talking about is because of direct heat of sun. Direct heat coming from sun. It's like as we are going closer and closer to the source of light, like bulb or something, the air that is surrounding this bulb, surrounding this region, will be very warm, very hot because of the direct heat from the sun or direct heat from the bulb. Similarly, direct heat of sun and bombardment from our outer atmosphere makes this region very warm. Thermosphere. The term is called as thermosphere. And because of the same reason, that is high temperature and bombardment from outer space, right here we have this layer called as ionosphere. See, ionosphere is not a separate layer. It's a part of it's a part of thermosphere. Because most of the ionosphere is due to sun rays, and most of the ionosphere therefore dissociates after sunset. right? It does not exist after sunset. And when we study ionosphere, there's a lot of things to study in ionosphere. So we are discussing ionosphere separately. Ionosphere it has been divided in different layers altogether. There are layers like D layer, E layer, F layer, G layer, right? There were climatologists, geographers who studied atmosphere and found like Kenley, Heaviside, Appleton. They have categorized ionosphere as different layers, as sub-layers, and have differentiated them on the basis of the radio frequency, rather reflection of radio frequency that is done by radio waves done by ionosphere, one of the main function of ionospheres. So let us discuss this ionosphere one by one layers. So this is ionosphere during the daytime, right? This is ionosphere during the daytime. I'll enlarge this. Or we'll just first see the daytime, what is there in ionosphere, and then we'll see what is there in the night time. So first, this ionosphere has been divided in D layer, E layer, F layer. F layer is further classified as F1 and F2 layer. What are they composed of? Chemically, what are they composed of? They're composed of ions. Ions of chlorine, ions of fluorine, ions of oxygen. The ionization can take place because of intense heat or the direct heat of sun, and also because of ionizing rays from ionizing radiations from outer space. So the lowermost layer within ionosphere is D layer. It can reflect low frequency radio waves. It forms a density of flare, like the density of flare is the high. So the radio signals that we send are reflected by D layer, right? Like 7 megahertz or something like that, right? 3 to 7 megahertz can be reflected by D layer. It's lower. Then we have another layer called as E layer, right? This D layer is also called as Kenley Heaviside layer. Kenley Heaviside layer. And E layer has also been called as Appleton layer. Now E layer, right, can reflect medium frequency waves, medium frequency radio waves. Then comes this F layer. F layer can reflect high frequency radio waves, right? High frequency radio waves. So what is the function, what is the significance of ionosphere? Ionosphere is very, very important because it helps us in the radio communication. See, satellites were in 1956, the first satellite was launched, that is Sputnik. And satellite communication is post 1950s. But we had radio communication prior to 1950s. Second World War it was there, prior to the First World War it was there. So radio frequencies, how did we get, what was the reflecting point? Today we can say satellites reflect signals and then they are amplified on the surface of Earth. So transponders which are today, what acted as a transponder for radio waves prior to World War or prior to launch of satellites? It is ionosphere. Ionosphere spreads, rather it reflected radio signals, radio waves. D layer can reflect low frequency, E layer medium frequency, F layer high frequency radio waves can be spread. Right? They can be reflected from there and helps in radio communication. Right? Now all these layers start disappearing after sunset. So we don't have a separate layer called as ionosphere because the dissociation starts after sunset. So we also have this layer. Let's bring in this layer as what happens during the night time. So this is night. We do not have D layer, no D layer, no E layer, right? Both of these dissociate after sunset. So what keeps intact is F layer, and what keeps intact is the G layer above this. Right? They're located at a height of almost 350, 400 kilometers. So at that time, it doesn't matter whether the temperature is high or low, or the sunset or sunrise. So heat hardly matters. It will anyway sustain there. Right? So suppose whichever place you are right now. So during the daytime, you will have a D layer, E layer, F layer, all layers well established. But after sunset, like suppose you go to this ionosphere after 8 p.m. or 9 p.m., you will not find D layer, E layer and F layer. Right? A part of F layer is now visible, but not the lower layers. They dissociate after sunset. Now the question is, some of you must be thinking, then how do we have radio communication during the night time? See, present communication is mainly based on the geostationary satellites, so we don't have to worry about the ionosphere anymore. In the radio communication, if it is night in India, it will be daytime in Arabia. It will be daytime in western part like Africa or Europe. So we have to match the frequencies with them. We have to get the frequencies with them. So if the countries have good relations, they had good relations, so they would share the frequencies with us. Right? And same thing, India will also reciprocate, because when it is daytime there, it can be nighttime there. So this is the main significance of what we call the ionosphere and the function of ionosphere. Right? Now outside this, so what we have covered so far is the lower layer. Right? This is supposed troposphere. I will not pay much attention here. Stratosphere, mesosphere, and this is all thermosphere and ionosphere, in which D, E, F layer are located. Beyond this, if we reach to this particular layer, it is called as magnetosphere. Magnetosphere. What is meant by magnetosphere? It is the layer up to which magnetic lines of Earth reach. Magnetic lines of Earth reach. See, Earth is a huge magnet, not by the gravity, but by the exact, we often say gravity, to refer to gravity, we say the Earth is like magnet, it attracts everything. Fine, that's gravity. But it is also like any other magnet, having magnetic north pole, magnetic south pole. Earth also has its magnetic north and magnetic south. And like any other magnet, there are magnetic lines from north pole of Earth to the south pole of Earth. These magnetic lines are very important for direction and navigation. So magnetic lines reach up to the magnetosphere. So if I have to show the magnetism of Earth or magnetic lines of Earth, suppose this is Earth, right? These are strong magnetic lines of Earth. You must have seen this diagram or this region. So this is how magnetic lines are aligned right now. This is north, this is magnetic north, magnetic south, right? So like any other magnet, Earth is also a huge magnet. It releases these magnetic lines in atmosphere. This magnetic line reach up to the layer of atmosphere above thermosphere. We call it as magnetosphere. So what will be in this magnetosphere? Very strong network of magnetic lines, strong network of these magnetic lines, right, interacting. Magnetic lines, what is the function of magnetosphere? It prevents Earth's atmosphere from external charged particles. High energy particles are stopped by magnetic lines. See, outer space is full of reactions, lot of nuclear fusion takes place there. So a lot of charged particles are bombarded. There's a bombardment every time. So many charged particles can enter the Earth's surface also. A stream of protons, which is called as cosmic rays, right? A stream of protons called as cosmic rays. It's like H positive, H positive, H positive. That is stream of protons entering Earth's surface space, Earth's atmosphere. They can enter the Earth's atmosphere and can cause bombardments. We will not be having oxygen. It will not be suitable for life. The magnetosphere actually prevents the entry of these high energy particles, right? and these high energy particles are actually absorbed. High energy particles are actually absorbed by the magnetosphere. By magnetosphere at different wavelengths, right? At variable wavelengths. And these, because if there are wavelengths, there are different colors, right? It is same, it is this belt, radiation belt is called as Van Allen's radiation belt. Van Allen's radiation belt. A very strong radiation belt formed in the magnetosphere. What is happening in magnetosphere? What is the radiation? These high energy particles enter the Earth's atmosphere. They are actually absorbed by magnetosphere, and the charged particles vibrate in these magnetic lines, and that magnetic line, that belt is called as Van Allen's radiation belt. Because they vibrate at different wavelengths in the magnetosphere, they also exhibit colors. These colors, this phenomena is called as aurora. Different colors are exhibited. I am repeating again, they are exhibited because high energy particles are absorbed at different wavelengths by the magnetosphere. It's like TV channels. We have one TV, one television, one receiver, but multiple channels, hundreds of channels. Why? Because every channel has its own bandwidth. Every channel has its own frequency. Similarly, exactly in the same manner, this magnetosphere receives these high energy particles at different bandwidths, at different frequencies, and therefore exhibit multiple colors. This phenomena is called as aurora, A-U-R-O-R-A, aurora borealis in northern hemisphere, in North Pole, aurora australis in South Pole. Why only in poles? Why not at equator? The simple reason that magnetic lines are stronger near poles. Where do we have stronger magnetic lines? Near the poles. So they attract these bombardments, these particles there in these polar areas. So Norway, Sweden, Denmark, Iceland, they'll see extremely beautiful colors in sky at times. That is aurora borealis. The same thing if it is seen from Antarctica, it is called as australis. Right? This is about magnetosphere, and this is about atmosphere, various layers of atmosphere, how it is done. Remember these points, read your NCERTs carefully. So after having discussed the structure of atmosphere, now we will be discussing another basic concepts related to climate itself, changes in the weather, seasons, etc. Let's go step by step now.